Okay, so we started with these in the bell work just to announce what we did in class. Feel free at home to play along and try to get these answers, but real good stuff. You guys can't see this because I've paused. This is what we are showing on the video. Whoops. And then I just hit that randomly. All right, you can see we got some stuff to do here. Okay, so input, say it. All right, it's going to be a lot of that today, and that's what we have to think about when we're doing an inequality solve. That's what we're moving to. I think you're really going to like this, especially if you're struggling on your unit circle values. Because the way the Mrs. Cooper slash Gray organized the notes from looking at other resources, it's really helpful thinking about the unit circle and just specific values. And it's actually really tied to the last 2 out of 3 quizzes that we've done in class. The specific questions, remember these, where I asked, what's the sign of 0? What's the sign of pi over 6? What's the sign of pi over 4? What's the sign of pi over 3? What's the sign of pi over 2? Then you saw the progression of the order of those output values. Then it did the same thing with cosine and the same thing with tangent. And this is going to come about here. But I see a lot of you guys knocking around in your brain up at the boards those same values and doing pretty well. Inputs, it. So one thing you could do is think about a graph for input output. All right. In this first one, by the way, what is this a function of? What is this a picture of? Sine or cosine? Which one is it? It's sine. And actually, if I really analyze this, it goes from 2 to -2, and the period is 2 pi. F of x would simply be 2 sine of x, right? Isn't that graph? Just an amplitude of 2, and we can say amplitude with sine because it is a high and low point. So where's 2 sine of x greater than 0? Just adding that in there. We can just leave this as it is and analyze the input output. You don't have to say that this time. All right, what kind of outputs do I want? Ones that are greater than 0, which are the values that are above the x-axis. So these are the output values. Very simple when we look at a picture. And look at the directions, which is common directions. We're going to sink it down a little bit. But for this one, it's pretty easy. So what are my inputs that make this happen? Those are the x values. And then notice it does say equal to's here, 2 pi and -2 pi. Oh, but this doesn't say equal to. So is -2 pi a solution, yes or no? No, because -2 pi is a 0. 0 is not greater than 0. So what do I need? A parenthesis or a bracket? It's parenthesis. So it's -2 pi to -pi. Same reasoning. Union. -pi is a 0 as well, so it can't be included. And then 0 to pi. All right, and then that's it for that little. But how long does this graph go for? For anyone? Forever. So there's a forever amount of intervals. The next one and the next one. That's why we want to sink it down to a specific interval and not have to write every answer, which would be impossible, to be honest. This one's a little bit more complicated because I did not get all of my graph. Now, I did let something leak out first hour, and we are going to graph this. This is actually a cotan graph. Don't worry about it. You can think of it as a flipped, right? Because tangent goes like this. A flipped tangent, but also shifted, because tangent's supposed to be between -pi/2 and pi/2 for asymptotes. So we'll just leave it at that. But input, say it. I'm looking for the graph where that is where below, right? Less and equal to. So let's really hit those equal to points. Those now count, and all of these outputs count. But we got a problem. The directions say from -2 pi to 2 pi. You didn't get all the graph here. So you have to revert backwards and understand that this is -pi/2. Okay, and I know I cover the screen here, but you can see the screen on the board. I just like to know that we're live in class. And then this is this graph, right? See, that's another piece. All right. Oh, okay. And then I have to keep going and leak into this question. This is at -pi. Oh, sorry. Just -pi. I said it, but then I don't know why I kept writing. And then up to -3 pi/2, we have another point. So up to -3 pi/2. Wish I had a little bit more room and planned a little bit better that I wouldn't leak into the previous question. But hopefully you get it, that these values as well count as output values. So it is a bit of an annoying answer. X equals, okay, we got a problem. This is equal to, so the zeros have to be part of this. Negative 3 pi over 2 is a 0, but the asymptote negative pi can never be part of the solution set because that's where the graph is undefined. I don't get an output value there. All right, and then the preceding other intervals, union, negative pi over 2 bracket to 0 parenthesis because of asymptote, and then pi over 2 to pi bracket parenthesis 0 asymptotes is the reason, and then union 3 pi over 2 to 2 pi. So that, see how this is something that we've already done. We've already done graphical analysis of inequalities. Sorry, I couldn't grab the word. But now we've graphed those so we can, it doesn't matter. You don't even have to know anything about tangent to answer this situation here. All right, this is what I like. Now, this one is a little enabling, giving you the whole unit circle. But then it really dictates how I'm going to show you the next one. Okay, so look at what we're doing. Our interval is shrunk from 0 to 2 pi, just like on 3, 4, and 5 up here. The whole idea of yesterday, changing it from, I know, those annoying inverse questions that stand alone. Number 2, you get negative pi over 6 because of rules. All right, but now we're back to this interval, 0 to 2 pi, and I want where sine of theta is greater than or equal to root 2 over 2. By the way, what sign? Is it the x coordinate or the y coordinate? Which one is it? What's the y coordinate? So we have to understand, and then this is where this is going to be helpful later. I don't find this to be helpful because this is copiers. I can just copy answers off of here without even thinking about my ratios. But it's okay. We'll use it. Isn't that satisfying the output condition, right? And then doesn't that mean that this is satisfying? Because this is what I was talking about. That's what I gave you that. What sine of 0? And sine of 0 was 0. And I don't want to highlight that because I'm trying to highlight what answers satisfy the condition. And then sine of pi over 6 was a half. And then sine of pi over 4 is root 2 over 2. And then root 3 over 2 for pi over 3. And then 1 for sine of pi over 2. So again, hammering that stuff down. That's why it's important to be in class and see all that stuff because everything builds and always have a plan. All right. And then this is still greater than, and then this is still equal to. So, and then when I look at all these, less than, and aren't negatives always smaller than positives, right? So the whole bottom half of the unit circle is irrelevant to this inequality. So inputs it. I want the inputs that make this happen. That's the inputs. It's the x's. Okay? So from pi over 4 to 3 pi over 4, and I'm going to include those because those are zeros, and this says equal to. Okay, so those inputs create the outputs that are greater than root 2 over 2. Got it? And this is how a unit circle can help. Kind of think it is the best way, in dealing with these. Okay? Kind of good stuff. It really brings you back to February 1st. If I want to look at the date, it's the first time we brought up the unit circle, and I keep saying because I feel like it was a long time ago. All right, now it's not filled in. Okay, AP. Let f of x equal. Let g of x equal. What are the values for from 0 to 2 pi when f of x is less than g of x? We know at this point all I do is do a flat out substitution. 4 plus 2 cosine x, and then less than g of x is 3. All I have to do is substitute and actually do what I did in the bell work with an equation. Reshuffle these things. Right? What's the first thing that I would do in this equation? Subtract 4. Okay, so we got to be able to work algebraically. A little worried about the algebra skills first hour. Going to hurt me on the board here. Some of the things that we're getting, and we're just reshuffling the equation. All you guys reshuffled your equation, I think 100% correct, but almost everyone kept everything negative. Just remember that you have a choice. I never like dealing with a leading coefficient that's negative. So multiply both sides by a negative is always a nice tool. But algebraically, second hour, you guys were really good. I just tried to help you out on that from before earlier in class. Okay, then that's what I got. So my cosine of x is less than negative a half. Where does that occur? All right. Now we're going to the unit circle without copying. And honestly, I would do this every question for practice. All right. What's cosine of 0? And all I'm going to put is I'm going to put the cosine values all the way around because this is a cosine question. So what's cosine of 0 when this is 0? I'm sorry, 1 comma 0. What's cosine of 0 radians? 1. And then what's cosine of pi over 6? Square root of 3 over 2. See, that was the whole point of that quiz is it goes down. Cosine of 0 is 1, and then it goes down. Root 3 over 2 is higher than a half. This is always root 2 over 2. This is always 1 half. And then that means cosine of pi over 2 is 0. So just filling in and now seeing the pattern symmetrically. This is what you had to do when you were doing your, filling in the unit circle originally anyway. I stopped for a second because what's cosine in quadrant 2? Negative, and then symmetry. So it just reiterates and reaffirms these values. And then this is negative 1. Writing. But oh well. What's cosine in quadrant 3? Negative. So then it builds back up. Negative root 3 over 2. Negative root 2 over 2. Negative half. Got a little chicken scratch there. And then 0. And then what's cosine in quadrant 4? And then it's a half. So cosine of over 3s are a half. Cosine of over 4s are root 2 over 2. Cosine of over 6s are root 3 over 2. Now, this could get a little weird, but let's make sure we understand it. Oh, and do understand this. I have to flip my brain as well for negatives. Who's bigger, negative 1 or negative 2? Simple question. Who's bigger, negative 1 or negative 2? Negative 1. So less than negative a half is a negative with a higher numerical value, huh? Now, you notice what I just said there? So less than negative a half would be negative 1, right? Okay, so less than negative a half would be a negative higher numerical value. That's what I said. Have a good day. All right, nice to see you again. I do like seeing you daily. All right, so we'll just keep doing it. Yep. All right, so anyway, less than negative a half. All right, so let's get the highlighter out for those. Less than negative a half are numerical values that are greater than half, right? Got it? So negative 1 is less than negative a half. Oh, I have to keep checking myself because of the, it's a backwards thinking. It's hard to think that. Oh, what's nice is that then it just keeps going to this right here. And then all those other ones are positive to right. Those can't be less than, right? So those are the outputs that work. I need the inputs, which are these. All right? Now, I do expect, did I do something wrong? What's wrong? Huh? Oh, I agree. But that's my ending parameter. What am I going to put on the answer? Parentheses. So I do have to I can't stop at 5 pi over 4 because all the angles between 5 pi over 4 and 4 pi over 3 work, right? So I can't stop at 5 pi over 4. So that's I'm glad you said that because that would be a mistake. All right. So how do we cover that? Good question. X equals parentheses. You do have to start at 2 pi over 3, but I just can't include it. It's right after 2 pi over 3 as a decimal radian that you would get a output value less than negative a half, all the way up to 4 pi over 3. So good. Glad you raised your hand on that. We can clarify that. I will have people that will say 3 pi over 4 to 5 pi over 4. Nope. You missed all of those angle measures. You missed all of these if you did that. All of those angle measures work as well in between there. Okay? It's a good question. All right, AP, let H of X, K of X, blah, 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 blah. All right, sorry, AP, but sometimes you drive me nuts. Okay, these aren't as bad, though. 3 cosine X. I know what you're trying to do. You're trying to get the students to understand math language and prove that they know math language. Got it. All right, so 3 cosine X greater than root 3 plus cosine X. And then do what you did algebraic. Unfortunately, it's a cosine again. We could almost use the previous one for this, right? Because then we just have cosine. Okay, what do I do first? Subtract cosine X. That makes this 2. Someone asked me, where'd you get that 2 from? 3 minus 1, right? And then greater than root 3 over 2. I could do it real quick. Just reiterate these over on this one. And I'll show you when I don't have a coordinate plane what I do real quick. And that's coming up shortly. I think I went ahead. I went ahead and divided by 2, didn't I? Didn't I? Yeah, so sorry. Doing 2 things at once and I tripped there. So cosine of X, fine, let's write it. We got the space. Cosine of X greater than root 3 over 2, and we'll write the answer off to the right. Okay, this one's kind of a pain because of the direction 0 to 2 pi, if it's the one I'm thinking of, what happened. Okay, remember, 1, root 3 over 2, root 2 over 2. It's not going to take me long. Half, 0, negative, leaked, negative root 2 over 2. I guess I'll sneak this like right here. Negative root 2 over 2, negative root 3 over 2, negative 1, and then negative root 3 over 2. We could have used these values to graph. This is what we did when we graphed. We actually filled out a chart of values. That's why I was hoping these would get a little quicker memorized by the group. All right, so just real quick again, cosine. It's exactly what I just filled in the last one. Greater than root 3 over 2. This is where this gets a little rough. Greater than root 3 over 2 is this interval from here to here, right? And I'm going to include those, but I'm going to put what on the answer? Parentheses. And then, is that it? Yeah, that is it. That's all those negatives. Here's what's annoying about this. The directions say just from 0 to 2 pi. I know what you might want to do, which is a more direct answer. Negative pi over 6 to pi over 6, right? That's in a number line order, but negative pi over 6 is not in this interval. So I have to split these up. I have to say x equals 0 is in between 0 and 2 pi. So bracket 0 to pi over 6. What do I put on pi over 6, a bracket or parenthesis? It has to be a parenthesis. Then honestly, this happens later. I think our authors of these notes made a little mistake. This should not say equal to ever, because 0 and 2 pi are coterminal. 0 covers 2 pi. So go ahead and cross that off because of what I'm going to do next. All right, that's usually what happens. But they may have copied this from another thing, and I'm a little confused why that would say equal to there. Then union, then go to 11 pi over 6. Why? 11 pi over 6 is in this interval. It fits between 0 and 2 pi. You got to think of a number line. And what do I put on that, a bracket or parenthesis? It's a parenthesis because of the inequality. And then this what might blow your mind, but this should be a parenthesis because this is a redundancy. 2 pi is 0. It's coterminal. You're like writing the answer twice, and they don't usually like that in math. That's why I don't think that should be an equal sign on that 2 pi. All right, you can read all this. One thing is going to happen right away in the step 1. Feel free to. That's fun for you. Here's what I don't have. I didn't want to print page 3 because here's all page 3 is. It's just 3 simple, quick questions. You can stick this wherever you want in your notebook. This has a lot of space here. You probably could fit it here more than likely. All right. Or put it on a separate sheet, like I said. Okay. Because here we go. And watch what happens on this one. There you go. See? Look at these directions. I think that's the correction. See how that says less than, not equal to? That's what it should say. So that's why I did what I did on the last one. Okay, here we go. What do we do first? Divide by what happens to the inequality when you divide by a -2? It flips. If you don't flip, you get completely the wrong intervals. You get the exact opposites of the intervals that you're supposed to be getting. Okay, you can either go to previous graphs or watch how fast this is. I'm going to go to a coordinate plane, and you may not have to do them all. What kind of angle measure do I get root 2 over 2 for sine? Pi over 4. So I could literally just go to pi over 4 and know that this gets me root 2 over 2 for a sine value. I'm not going to write the full coordinate. I'm just going to write the output value for sine there. All right. And then here, this is where sine is 0. This is where sine is 1. Okay, so this could be enough. 3 pi over 4. What's the sine of 3 pi over 4, everyone? Positive or negative? Positive and what? The same thing, root 2 over 2. So this is enough to understand that I am at this interval, whether you want to choose blue or green or whatever. Those are the output values that are greater than or equal to root 2 over 2. All of these are less than that, and all of these are what kind of number? Negative, which is irrelevant. Negatives are not greater than or equal to root 2 over 2 for output values. So literally, that's all I have to think about. I don't have to draw the whole unit circle. I got to know ASTC and know all the bottom ones are negative. Those outputs don't work. All right, now what do I do? Brackets or parentheses? Brackets all the way. So it is from pi over 4 to 3 pi over 4. All of those output values, when I sign them, sign those angle measures, are root 2 over 2 or higher. So again, knowing that progression, this is why we never did inequality solving before, but it actually ties a lot of things together. It really does. Losing my voice there. Oh no, we're going to need a full unit circle on this because we haven't done tan yet. What's the first thing you're going to do? Subtract what? Okay, subtract root 3. Always get sad when it's these things that trip up the students. That's not the trig. That's what you came in here with. Those bad math skills. That becomes a -2 root 3. Negative plus a negative is 2 negatives. -1 plus -1 is -2. That's why it's -2 root 3. Do I flip the inequality when I divide by 2? Yes or no? Some people are robots and they see a negative and they say yes. You didn't divide by a negative, so no. All right. I'm going to do a little bit more complete on this. But here's what you're going to do, just real quick. Yoink, yoink, yoink. Just get your 3 positions, and then just get ready for the output values. Not good at all. All right, but at least I know my 3 positions. Maybe change colors if that doesn't stick out enough for you. But tan of 0, this was on our quizzes, 2 of the last 3. Actually, 4 times, 3 times we've had these questions. What's the tan of 0? Well, the tan of 0, 1 comma 0 is that point. 0 over 1 is 0, right? What's the tan of over 6's? Is it root 3 or root 3 over 3? See, there we go. Now it's symmetry. Root 3 over 3, 1, root 3. Uh-oh, what's tan of 90? Undefined. 1 over 0, that's where we get undies. That can never be an answer. All right, and then symmetry and also tangents negative in quadrant 2. You see, this has got to start infiltrating your brain. Right? And this is those that are struggling. Wrong! What's tangent in quadrant 3? Positive. I accidentally put a negative there first, and that was a big accident. Undies, and then negative. Symmetry, negative root 3, negative 1, negative root 3 over 3. Okay, this is a problem because the answers are from 0 to 2 pi again, and I need less than negative root 3. Again, less than negatives that are less than, are negatives with greater numerical values. So, unfortunately, less than negative 3 is just this literal interval from here to here, because negative 1 is larger than negative root 3, just like negative 1 is larger than negative 2. Negative world. All right, and then where else do you have an interval that happens? Actually, this is not as bad as I thought, right? It's that little interval there. Very two small intervals. Now what you need to know is what are those angle measures. Luckily, x equals, this is a less than and not an equal to, so it's parentheses all the way. Pi over 2. What is this one? What is this one where you get pi root 3 over 2? 2 pi over 3. And then union that with, this is 3 pi over 2 down there. Can't help you if you don't know these radian measures. We're done with that. Got to know the over 3s and how we get that. I can't go back to February 1st. 5 pi over 3 is close to 6 pi over 3. I actually did that yesterday when we were doing the quizzes. Right, and then AP. Where is f of x? I'm going to go back up to that graph that I created for this because it is a tan. Is wrong, greater than or equal to negative 9. Okay, so where's f of x? F of x greater than or equal to g of x. Just do a replacement. I'm going to go back up to that graph. This answer is going to be annoying. Subtract 1. Come on, that's negative 10, not negative 8. And then divide by 10. Not a flip because I didn't divide by a negative. You should know right away what kind of angle measure cuts off where this happens. Pi over the over what? 4s. Okay, so I'm going to cheat and go to this graph. Here's where the over 4s are, or greater than or equal to negative 1. By the way, aren't all positives greater than negatives, right? Okay, so here we go. We're going to go in blue. Here's where this happens. So here's negative 1, greater than or equal to negative 1. Remember, values that have negatives are greater than when they're smaller, right? So it is that interval right there. Negative root 3 over 3 is greater than negative 1 because it's a smaller numerical value compared to that. And then positives are always greater than negatives, right? Right up to that. So the blue answers are for my next question. And then greater than or equal to negative 1 is this. This is where it gets annoying because that little interval does work. Sorry, I missed. I did that thing that you guys were talking about. I have to start at where negative 1 happens, and then all those values are smaller than that. Then this one. So I have to interrupt this answer, and I'm going to put this answer right here. You feel free because you can see I can't scroll. Okay, so for this answer, tan of x is greater than, I hope you guys know what you're doing here because this is quite complicated and you do this often. This is really complicated. So you shouldn't be doing your own thing right now. 0 to 2 pi. So I have to start here. Is 0 an answer? Yes or no? Does it satisfy this condition? The answer is yes, so it's a bracket. So I have to start here because the directions say I need answers from 0 to 2 pi. And then all the way up to pi over 2, should I have a parenthesis or a bracket on that? Parenthesis or bracket? Parenthesis, because that is a asymptote. That cannot be an answer. And then what do I do at, what's this one? 3 pi over 4, because it's the over 4s. What do I have on 3 pi over 4? Bracket or parenthesis? Why bracket? Because it says what in the inequality? Equal to. And then I get to go all the way to this one because all of these values are greater than -1. Positives are greater. So this is an easy analysis here. All right. But what do I put on 3 pi over 2? Parenthesis. And then union that. Why did I have to bust this up? Because I have to answer from 0 to 2 pi. So I have to go to this little interval and then that 2 pi, and then that cuts off the interval. All right. And that was the whole point of that. And then what's this over 4? I almost put 5 pi over 4. No way. 7 pi over 4 is close to 8 pi over 4. So it's bracket 7 pi over 4. And then why are we going to put a parenthesis on 2 pi? Because of the directions, but also because of a redundancy. 0 is 2 pi. You'd be writing the same answer twice. So that's why they usually cut it off at 2 pi. All right. So it can be complicated. And you got to do like that kind of analysis on this. So, all right, that's it. Don't want to blabber anymore about it. The situation is set forth.